Good morning, good morning. And again, I was excited to have some of the music when I came out. When I start these types of talks, I usually look in history and see what happened on June 4th to try and start out the event with maybe there was some geospatial event or something like that happened on June 4th. And what's unique about June 4th, nothing really happened. So I'll pick the closest event. On June 4th, 1984, Bruce Springsteen released the Born to Run album, so I was kind of hoping I'd come out to Bruce. My name is Alan Sonstaby. I'm the Deputy Executive Director at the Applied Research Lab at Penn State University, which is one of the 14 university-affiliated research centers. I'm going to talk to you a little bit about the university, what a UARC is, and then get into some of the geospatial research that we're doing, especially the programs that include students. So Penn State University, 162 years old, founded in 1855. One of the first land-grant universities in the nation, along with Michigan State University. It was Pennsylvania's original agricultural and mechanics university, the A&M. And I think you could make the argument that today, GEOINT is the A&M of the universities across the nation. Large university, on the order of 100,000 students across the system. A very strong research program or sponsored research coming in, $836 million. I think those are FY16 dollars. So lots of research going on, which we as a UARC are able to leverage. Again, we are a UARC. Our number one product that comes out of us is our students. So I want to put a slide up here to talk about the geospatial sciences education that we have available at Penn State. Everything from resident degrees with geography, your bachelor's, master's, and PhD programs, online programs, Master of GIS with a GEOINT option, Master of Professional Studies in Homeland Security, also with a GEOINT option, various certificates. You can read the certificates up there. And then what's interesting, if you haven't dealt with MOOCs or the massive open online courses, you ought to try it. So if you're looking at dipping your toe into the GEOINT education or the online education, I would encourage you to look at the MOOCs that are available across the universities. And again, there's professional development programs as well. So UARCs, I mentioned there's 14 of them, university-affiliated research centers. So our history, we grew out of the Harvard Undersea Sound Laboratory. After the war, Harvard wasn't looking to do classified research or applied research. So at the time, the deputy director of the laboratory is moving to Penn State to head the electrical engineering department. And the Navy asked him, and on a handshake, he brought 100 or so engineers from Harvard down to the university. Fast forward a little bit to the mid-90s, the DoD was struggling to how do they define these organizations at universities that are doing this applied research. And what grew out of that studies was the designation of UARC, University Affiliated Research Center. Currently, ARL at Penn State is the largest interdisciplinary research unit at the university. We're about 1,200 faculty, staff, engineers, and students. Lots of research and laboratory space. And how we're organized, we have 4 thrust areas within ARL, mission focus areas. Our legacy areas are fluid dynamics and acoustics, undersea systems, and our relatively new areas are material and manufacturing sciences, and communications, information, and navigation. And that is really where GEOINT lives within the Applied Research Lab at Penn State. I'll put this up here. These are the key research areas, focus areas that we have at the lab in the GEOINT area: image processing, computer vision, image and point cloud-based feature extraction fusion, geospatial analysis and production. So what I want to do now is how did we get to this point? And again, lots of universities are doing research in this area. But does anyone have any idea where GEOINT research really started in support of military intelligence? And the semester just ended at Penn State, so I'm in teaching mode here. Any ideas where it started or when it started? Just like class, nobody wants to raise their hand. So think to 1804. So at the time, Jefferson was president. The Revolutionary War is still in everybody's mind. And the president is looking around and saying, well, I've got the Spanish to the south. I've got the French in the country as well. Not really sure what's going on towards the west and the northwest. So what did the president do? Lewis and Clark. He said, I'm going to put a cadre together. I want them to map out the area and lay claim to it. So GEOINT really started, and you can, within the US with Lewis and Clark, and there's some differing opinions, but most people accept that. Fast forward now from 1804 to 2010. In 2010, the National Research Council, at the request of the NGA, explored some areas that were emerging that could potentially improve GEOINT. So when I read these areas, think about the mindset in 2010 that we were even asking, could these potentially improve GEOINT? GEOINT fusion, crowdsourcing. And remember, in 2010, crowdsourcing was a relatively new term because it was just, I think it was Jeff Howe in Wired magazine in 2006 that coined the term crowdsourcing. Human geography, the social networks, visual analytics, and forecasting. So when you look at those, go back one slide, please. Yeah, when you look at these areas up here and you look at what we were thinking in 2010, look how far we have come just in these seven areas. Peter, in his briefing, talked about visual analytics, and while we've all heard about the immersive reality, we're getting more and more into augmenting reality, the AR technologies, and those are tools that are going out to help our analysts now. Now I'm going to get into the students and then talk about what we're doing with students in the GEOINT program. One of the responsibilities of a UARC is to develop students and help develop the future workforce that will support national security, whether at a contract or in the government or staying in academia. Every year we have 250 to 300 students supporting these programs, and typically this is, at the undergraduate level, this is their first exposure to GEOINT. So the next two slides will discuss a GEOINT effort that's largely being driven by the students with some support by faculty advisors and ARL researchers. And at this time, I also want to give a plug for the poster session back there. Make sure when you go for your snacks, check out the posters and use the app and vote for the winners. So we've been using open source NGA tools, GeoQ and Mage, and set up an ecosystem for students that are part of the College of Information Science and Technology Red Sail Analytics Lab, the Applied Research, and some other colleges to develop tools for disaster response and situational awareness. So you can see on the lower right our GeoQ test bed. So 6 times a year, our stadium becomes the 3rd largest city in Pennsylvania. And what comes with that are all the problems that a 3rd largest city would have. There's people that don't get along, there's degraded comms, and there's many simultaneous scenarios. Number one being a football game, but there are medical emergencies, there's There's other issues that go on. So these students have been putting together tools on how to develop situational awareness and also bring in analytics to it. So you can start seeing, okay, well, I've got this sector, we always have a problem. This sector, we typically see that. Is it a Big Ten conference game? Is it a noon kickoff, 3 p.m. or 8 p.m. kickoff? Is it bowl game implications? All of those fold together to help with the analytics. Part of the demos, the stakeholders that we have attending when we do these sessions, we have NGA, we have FEMA, FBI, local law enforcement, state law enforcement, and we've really developed a COP. The students have developed a COP using this ecosystem. So there's one example of the crowdsourcing I talked about. Where are the students going now? I'll let you read the list up there. User interface enhancements, data service ingestment, the mobile apps, integrating different tools, different analytics. But again, it's bringing in students. So think how valuable these students are if they start this type of work as a junior. When they graduate, look at the background they already have. Being part of a major research university, the students have access to all sorts of analytics and tool sets that have been developed by research. So I just wanted to put up here, Peter talked about AI and machine learning. Again, there's all sorts of research tools available that the students can then pull in to this open source development environment with deep social network analysis, automated text analysis, behavior forecasting. And again, that's the strength of a UARC as well, because we are all located on major research universities. So last slide, I want to put up some areas that we're currently working on. You can read them, but it's the, again, situational awareness. We're heavy into the analytics, the merging of geo and cyber. Again, Peter mentioned that. We're working that area. But I want you to think back to that list from 2010 that I put up. What's next? What are the enablers that are going to help us develop new emerging areas for GEOINT? Who's familiar with 5G? 5G comms. So if you were at the Mobile World Congress in Barcelona in February, you would see that 5G is real. Verizon will be deploying it later this year. So what does 5G get you? They haven't defined what the actual spec is, but you'll be getting 10 to 20 gigabits per second to your mobile device. Probably more important, the latency. You'll have latency of sub-millisecond. So what does that mean? So when you do your speed test on your mobile device or at home, you're typically getting 25 to 32 milliseconds. When you're sub-millisecond, you can real-time interaction between your sensors. IoT, Internet of Things. That's coming. We've all heard about it. The chip maker ARM, which probably builds the bulk of the IoT processors, reported they plan to ship over 1 trillion devices in the next 20 years. So 1 trillion. Those are the things that will be in your washing machine, they'll be in your shoes, they'll be in your car will have multiple of them. Think of all those sensors that are collecting data that'll be supporting GEOINT. Peter mentioned AI and machine learning. So if for the science fiction readers in the audience, if you go back, the writers would talk about reaching the singularity, the technical singularity. And that's when computers will surpass the human brain as far as AI. So at the time, it was only coming out of, historically, it's only been coming out of the science fiction writers. But now you're seeing scientists, you're seeing industry, for instance, SoftBank over in Japan, making huge investments into AI. Matter of fact, the CEO of SoftBank is predicting we will reach the singularity within 30 years. I'll recommend, actually the CEO of SoftBank, Masayoshi Son has a really good YouTube video of his Mobile World Congress talk where he talks about the singularity. I encourage everyone to check that out. It's very interesting. I don't come down on either side, so I'm not advocating that it will happen within 30 years. I'm just saying other people other than the science fiction writers are talking about it. So last point, with all of these changes happening, what are the emerging enablers that will support GEOINT in the future? We've seen the curve of capabilities from 1804. We've been accelerating faster and faster with our capabilities. We just saw between 2010 and 2017 today what we have. So in the next 10 years, what will we see? The folks at this conference a decade from now, what will it be like? So think about that. Thank you.
Good morning. Next up, we're going to have Brian Springer from Georgia Tech Research Institute. Please help me welcome Brian to the stage.
Good morning, GEO community. Glad to be back here in San Antonio. I recently retired from the Army. It's hard to follow up these two doctors here. We had Peter and Alan up here. They're very good speeches, so here I come up here as a retired military guy, but it's always good to be back in San Antonio. So it's almost like home for me, so it's always comfortable for me to be up here. So good morning again. My name is Brian Springer. I'm one of the senior research scientists at Georgia Tech Research Institute. And today I'll give you a quick overview of both Georgia Tech and GTRI, Georgia Tech Research Institute. Here's the agenda that I will follow today. I'll give you a little background on both Georgia Tech and GTRI. We'll talk about how we operate as a UARC, and then some of the ways that you can reach Georgia Tech through contracts. And then I'll talk specifically about some of the programs that we have in place to support the GEOINT community. A little history about Georgia Tech. The Georgia Tech campus wasn't always the sprawling campus that we have in Midtown Atlanta today. Way back when we first started in 1888, it was only 2 buildings you see up there on the top left. 4 short years later, the building on the left burned down, and we reconstructed the second building without the tower. It was in that building that Georgia Tech Research Institute got it started. It was first called the Engineering Experiment Station, and then later changed its name in 1984 into Georgia Tech Research Institute, as it is today. So again, as I mentioned before, I recently retired from the Army, and I've only been at GTRI about a little over a year or so. But one of the best things that I've noticed about Georgia Tech and GTRI is how they're both fully integrated. This is a real strength for GTRI in that we have a deep bench of not only researchers at GTRI, but also at Georgia Tech main campus. In addition to that, we have 20,000 of the best and brightest students in the nation that we can tap into. Georgia Tech has really grown into an extraordinary institution over the past number of years. Last year, we were ranked number 4 in undergraduate engineering, behind only MIT, Stanford, and Berkeley. All of our engineering programs are in the top 10, and some, like industrial and aerospace, are always number 1 and number 2 in the nation. This brings tremendous credibility when we go out and meet with and talk to potential sponsors in the community. And it's something that we're truly proud of at Georgia Tech, especially the many graduates of Georgia Tech that we have within our ranks. GTRI itself hires more Georgia Tech graduates than any other employer in the city of Atlanta, and we're very proud of that. In terms of overall Georgia Tech enterprise, GTRI really is a very significant part of it. We represent about 1/3 of the total faculty and more than half of the overall research budget. So most people know Georgia Tech as a degree-granting institute with our 6 exceptional colleges, specifically the College of Engineering. There are also 3 other pillars that make up Georgia Tech's innovation engine. Georgia Tech Research Institute, the organization that I represent, is listed there in the top left, and I'll get into that slide a little bit more later. In 1996, the Enterprise Innovation Institute was spun out of GTRI to provide a more visible and dedicated focus for economic development in the state of Georgia. The 4th pillar is the Georgia Tech Global Learning Center. and the Georgia Tech professional education programs. At GTPE, we deliver in-residence and on-site short courses focused on a variety of topics. So now let's dig a little deeper into GTRI itself. The core operating function for GTRI is its research labs. GTRI is structurally organized into 8 labs grouped into 3 directorates: the Sensors and Intelligence Systems Directorate, the Information and Cyber Sciences Directorate, and the Electronic Optics and Systems Directorate. Again, I fall under the Information and Cyber Sciences Directorate. Most of these labs are located in and around our Midtown location, just co-located with the main campus of Georgia Tech. But we also have 2 labs out at our Cobb County facility that falls within the Sensors and Intelligence Systems Directorate, and we have 1 lab that's located down in Huntsville, Alabama, right next to Redstone Arsenal, that falls within our Electronics, Optics, and Systems Directorate. They're actually one of our largest labs and one of our largest field offices. Last year, we conducted over $360 million in sponsored research. Between all of our locations, we have over 1 million square foot of research space. About 12,000 of that is SCIF space. We also have 18 field office sites strategically located throughout the nation. We have one right here in San Antonio, where Mr. Jim Healy is the site manager for that site. As I mentioned in the previous slide, we are fully integrated with the academic side of Georgia Tech. In fact, we have about 300 or so students, both graduate and undergraduate, that work within GTRI workspaces. As you can see in the pie chart there, our research is split pretty evenly amongst the Army, Navy, and Air Force. Over 90% of the work that we do is for the DoD, but we do have a small footprint in both the state and local government and some private industry work. As far as our role as a UARC, we've only been designated as a UARC for about 20 years or so, but our work within the federal government space goes back for decades. In fact, some of the programs that we have been in existence for over 30 years. And just like all of the other UARCs, we operate in the public interest to maintain essential core research and development capabilities for the DoD. Our actual UARC charter is held with the U.S. Army Aviation and Missile Research Development Engineering Center down at Redstone Arsenal, which is the reason we have one of our larger labs located down in Huntsville, Alabama. So this slide here just shows some of our core competencies as a UARC, and as you can see, we have a broad spectrum of competencies within GTRI. So just about every time I meet with potential sponsors, I eventually get asked, how do you reach GTRI? Well, this slide kind of shows some of the ways that you can reach us. Obviously, if you have work that's fit in one of our core competencies, you can use the UARC vehicles, UARC contracts, and sole source directly to us. But we also are part of the Defense Technical Information Center, Cybersecurity and Information Systems, and Defense Systems Technical Area Task, or the CS and DS TATs. These are a group of organizations that are primes on these contracts and work with DTIC to do programs through DoD customers. So now let's talk specifically about some of the programs that we currently have in place to support the GEOINT community. As I mentioned earlier, I fall within the Information and Cyber Sciences Directorate, and most of these programs are from other directorates, so I'm not the SME for those. However, we will have SMEs at our booth in the exhibit hall at booth 1018, so I invite all of you to come out to our booth and pick the brains of our researchers if you have any deep questions on any of these topics. So first, let's talk about machine learning. GTRI researchers are using world-class expertise to reduce machine learning time through synthetic training models and novel uses of high-performance computing. Our goal is to perform real-time object characterization and full scene understanding at the sensor. This will enable technical collectors and operators to react more quickly to what is happening directly before them. This technology being implemented on GTRI unmanned vehicles and is leading to the development of unmanned sensing platforms to dynamically carry out ISR missions without a human in the loop. Another capability that we're supporting the community with is our agricultural sensing for W&D facility detection program. GTRI has conducted internally funded research to innovate new ways of detecting changes to plant health and growth. These include inventing a new microgas chromatograph that fits on unmanned vehicles. This sensor technology, along with research using machine learning for processing multispectral images, has opened the door for new ways to assist remote sensing missions in detecting facilities of interest related to WMD and CBRNE activity, chemical, biological, nuclear activities. GTRI is a world leader in radar signal processing algorithm development. Among that is recent development of real-time airborne synthetic aperture radar, ground-moving target indicator, and automatic target recognition. Having this capability in real time at the sensors allows for tracking of vehicles and dismounted persons. These algorithms can identify all moving objects in the scene and allow the user to select a specific moving entity to track and follow. The next program I'll talk about is the metadata-only non-ellipsoid area tracking, or MONET. GTR researchers developed lightweight code that shifts a long-held paradigm in the metadata analysis community of forming area ellipses to achieve target containment. Traditional area ellipses formation works well for a single set of collected data. When multiple collectors are introduced, the lack of access to raw collection data prevents accurate recalculation of geolocations. MONET overcomes this challenge and gives analysts an intuitive topographical picture of where the densities of points fall. This also overcomes collection challenges in environments such as mountainous terrain and urban areas. The final program that I'll mention today is the Multi-Domain Analysis and Deep Knowledge Association Toolkit, or MADCAT. MADCAT uses high-performance computing and patented data classification algorithms to assist analysts in pouring through big data. These algorithms measure user feedback and learn from user interaction with the data to improve performance over time. This human-machine collaboration leads to faster discovery of less obvious relationships with data to make significant discoveries within the data. This program also overcomes numerous challenges that analysts face when trying to correlate data, events, and data sets for multiple data sources and domains. So to sum it all up, GTRI is an integral part of Georgia Tech research enterprise, with the focus on applied technology and large-scale system prototyping. We have a vast amount of competencies that sponsors can tap into to solve tough problems. Our motto is problem solved. When you have a tough problem that you want solved, reach out to GTRI and we will be glad to work with you to come up with a solution. Again, please visit us in our exhibit hall in booth 1018. Thanks again for giving us this opportunity to reintroduce ourselves to this community, and I wish each and every one of you a fantastic GEOINT week here in San Antonio. Thank you.